Hi everyone, this is Sunny Kumar from IIT BHU and welcome to our channel Code with Sunny. Today I am going to discuss the problem valid stack sequences of index number 946 of Leetcode, and the problem is of medium type. Okay, so let's jump directly into the problem statement without wasting our time. So basically we have been given two sequences and the names are pushed and popped. Basically, these are arrays and with distinct values, and we have to return true if and only if this could have been the result of a sequence of push and pop operations on initially empty stack. That is, you can see an array of pushed and similarly an array of popped. We have to return true or false after determining whether these elements in pushed and popped are the valid sequence of operations for a stack or not. That is, you can see here, you can see first if we push 1, then push 2, and then push 3, and then push 4, and if we start popping 4, then push 5, and these are the sequences of operations. And if we do these operations, we have a what sequence of popped arrays. First popping is for 4 and similarly for 5 and 3. So we have this array of popped and similarly a sequence of arrays, sequence of elements for pushed, and we have the arrays like this one pushed for the sequence starting from beginning of the operations, and we have to return true if this can yield the what the correct sequence of the stack operations. Okay, so how we are going to do this operation in most efficient way, so let's analyze further. Sorry. Okay, now what is given in this question? Actually we have been given an array of elements denoting the say what pushed operations of the stack in sequence, and similarly we have been given an array of denoting the elements of popped operations in sequence. That is, if 4 is popped out first, then 4 should come in the array first, and then let's say 3 is popped out later, so 4 comes in array first, then 3 comes. Okay, now we have to check whether push as well as pop operations are valid operations of the stack or not. Okay, we have to return to now. Let's understand this question with certain examples. That is, suppose we have a pushed array this and popped array this. So how are the stack operations should be done so that this can be a valid what stack operation? So let's analyze further. Okay. So what I'm going to do is, suppose I have a pushed vector as this, and suppose I am going to take what let me take 1. So if you take 1, so I have a stack 1. Okay, now this is what top. Now if we take off, or you can see if we push 2 again, so I'm going to tick mark this, and if we push again 3, and if we push again 4, then you can see I have a stack like this 2, then I have 3, then I have 4, then this is what this 4 is at top. I'm going to denote it by T. Now you can see I have a sequence of what popped operations, that is as you can see here. Now 4 should be popped what first time. So whenever we encounter the what in my stack as 4, I'm going to pop this 4 out. Okay, let me write OUT. So if we pop out 4, then our stack will be what 1, 2 and 3. Now this is the state of stack now with 3 as its top element. Now you can see I have the next element as now I am going to tick mark 4. I have a next element as what 5, which should be popped out next. Now you can see I have to push 5 so that I can pop out what 5, which should be our next element of popping operation. So I am going to push 5, so I am going to write 5 here. Now you can see this is my what stack, that is current state of stack. Now you have to see I have pushed 5 and 5 is the stack top element, you can see here. Now I have to pop out 5, so I am going to pop out 5. Yes, 5 is popped out. I'm going to what let's say I'm going to rub it here like this. So if 5 is popped out, I have a sequence of stack as 1 2 3 with 3 as top. So I'm going to tick at 5. Now you can see 3 is the next popped out element, and 3 is also at the top of stack. So 3 is also popped out, and again 2 is also at the top of the stack, and you can see 2 is the next popped out. What operations I'm going to rub 2 again. Now 2 is also what popped out. Now you can see 1, and again 1 is also the what element of the top of the stack, so I'm going to pop out 1 again. So you can see stack becomes empty and popped operations are all done. So if stack is going to be what empty finally, then I'm going to say that my sequence of operations of pushed and popped are valid. Otherwise I'm going to say no, it is not valid. So how we are going to do these operations in most efficient way? So the best way is to, whenever we encounter a certain element, let's say 5, and whenever we encounter again the pushed top, that is stack top as what 5, then we are going to pop out 5 until we encounter the stack as non-empty, or you can say stack as empty, and the popped array top element, you can see, is exactly equal to what pushed, or exactly equal to stack top. Then I am going to do the pop operation every time. Okay, so let's take another example. So we have an example like this. Okay, so let me have a stack as S empty. Now I'm going to push 1, and note that I have 4, which is the popped array first element. So till 4 I'm not going to what pop out, so I'm going to push 2, push 3, and push 4. Now you can see I've encountered 4. So, and pop the first element is also 4. So I'm going to what? I'm going to pop out 4, that is you can see pop out 4, and now 4 is done. So I'm going to erase 4. Now you can see my top element is what 3. So I'm going to, and this is also 3. So yes, we can pop out 3 also. Now you can see 3 is done. Now you can see I have a top element as in the popped vector as 5, and you can see I have a 2. So I'm going to push more elements in my stack. It is 5 again. So I'm going to push 5. Now you can see I have a 5 here, and again at the stack top is 5. So I'm going to erase here from stack top 5, and again I'm going to erase this. Now you can see I have a 1 here, the top element, but in stack top I have a 2, and so I have to push more elements, but the in pushed vector we have exhausted what our elements. So this is my last what this is my stack what non-empty state after all pushing and popping what operations has been done. Okay, now you can see if our stack is non-empty, then we can claim that yes, we cannot reach a state where all the pushing and popping operations has been done. So it is basically what we have to return false here. Why we have to return false? Because these sequences of operations are not valid. So we are going to return false in this case. So what would be our sequence of approach to solve this problem? The best sequence of approach to solve this problem, whenever we encounter the element, that is popped element, exactly equal to the stack top, then I am going to pop out until the stack is empty, or I am going to pop out till stack top is not equal to my popped element. That is popped element from what popped vector. So now I'm going to pop out the elements until and unless then. Okay, so let us move to the approach. Note that our approach will be greedy, just implementation with a logic of what stack, push and pop operations. But note that I am going to use the space efficient approach. That is, I am not going to use the stack. In spite of that, I am going to use two pointers, I and j. I is going to what iterate in pushed vector, and j is going to iterate in what popped vector. Note that I am going to treat my pushed vector as a stack with the help of pointers. That is, pointer is going to move forward or backward with the what with as the popped element matches with the what pushed elements positions of I and j, you can see. Okay, now I'm going to maintain two pointers I and j for pushing and popping entries, and I'm going to treat my pushed vector as a stack. Now pop out the elements from the stack till stack top is what equal to popped array top, that is iterator j. That is or you can say in simple words, if let me write stack dot, if stack is non-empty, in concept of stack, if stack is non-empty and stack top what is actually equal to popped what, let's say j, you can have this statement. So but I am using the iterator here, so modified operation, you can say modified statement would be what, if let me write, if I is going to be greater than 0 and what, I have a pushed, I am going to treat my pushed vector as what, a stack, and pushed of I minus 1 is until and unless equal to popped of what, j. Note that j is for what, is for popped, so I am going to treat my j should be less than n, where n is what, the size of the arrays, given arrays. So I am going to do this here should be while loop, so this will be the condition of popping operations, okay, or you can say if we maintain pointers I am going to treat with I and j, okay. So if we have an empty stack at the end, that is check I equal to 0, then all the push and as well as pop operations are valid, then I'm going to return true, otherwise I'm going to return false, okay. So time complexity is O of n because I'm going to treat every element a single time, and our space complexity would be O of 1 because I'm not going to use any extra space, only pointers are used, okay. So pointers, or you can see variable, simple, so don't get confused. So let us move to the code. Okay, now here I have a code. I'm going to treat my push vector as a stack, maintain a pointer I and a j for in the what, in j is used in the popped vector. Now I'm going to initialize I and j with 0 and as a push dot size, or you can also write pop dot size because both sizes are same, okay. So I'm going to iterate in my pushed vector, and I'm going to first what, push that element into my pushed vector, that I'm going to push the entry. Note that I'm going to treat my pushed vector as a stack, so that's why this code is going to be what, memory efficient. Now whenever we encounter, or you can say whenever we found a popped vector top element equal to stack top element, or you can say element present at the iterator, or you can say pop the element from the top of the stack, that is I'm going to decrement my I, because note that I'm going to treat my push vector as a stack, only pointers are going to change, or you can say iterator I, and also from the popped vector. Okay, so the condition would be what, while I should be greater than 0 and j should be less than n, and pushed of I minus 1 must be equal to popped of j, then I'm going to decrement my I, that is denoting the stack top is going to be removed, stack size is going to be reduced by 1, and similarly I'm going to increment my j because I am done with this popped operation, that is this element has been what, this element has been removed from the stack top, so I'm going to search for the next element from the what, popped vector. Now I'm going to check if I is going to be greater than or you can say I, if I is going to be equal to 0, then this indicates that our stack is going to be empty, that is these sequence of operations are valid, so I'm going to return true, that is I'm going to check if I is going to be equal to 0, this will automatically return true. So let me submit this code and check out. I guess, okay, I have some network issues, like, okay, wait a minute. Yes, now it is working fine. Okay, so you can see here also. Let me show my accepted code at least. Okay, you can see here also I have the same set of code, and this is going to by 88% is my runtime beats. So you know you have no need to worry about. Okay, so let me have some look. Okay. So if you have any doubts, do not forget to mention in the comment section of the video. And I will ask the viewers to like this video, share this video, or do subscribe to my YouTube channel for latest updates. Thank you for watching this video.